Here we go. Last two types of questions. This is number 6. We're trying to find the actual zeros now. What we're going to do is we're going to employ the strategies that we had before and just look at the sign changes first. That's using the Kharsa Theorem. So if I look at my original equation, there's no sign changes, right? Which means there are right away 0 positive roots. Okay, so let's look at f of negative x and see if we can gain some more information. So f of negative x, that's going to be negative x cubed plus 9x squared minus 26x plus 24. So from negative went to positive, from positive went to negative, that's 2. And from negative to positive is 1, to negative that's 2, back to positive that's 3. So 3 sign changes, that means 3, oops, wrong color. That means 3 or 1 negative root. Yeah. All right, so I'm going to look for my negative roots. I know there's at least 1. And so the way I'm going to check that is first let's use the rational root theorem to figure out what are the possibilities. So here's the last number, right? P could be equal to anything that divides 24. Let's do that on the left here. P could be 1, 2, see 3 divides 24, 4 divides 24, 6, 8. This one's got a lot. 12 and 24. Q can only be 1, right? Because that's the coefficient on the original term, just a 1. Invisible 1 here. And again, these could be all plus minus. So that means the possible rational roots are plus, right, let's write this down. Possible rational roots plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. All right. Hopefully it's not one of the larger ones. So we're going to start with the smaller ones and see. Now, last section we learned how to check if something is a root by just plugging it in and seeing if it comes out to be 0, right? So we could do that. The other thing we could do is use synthetic division, and if we use synthetic division, the result will actually be something that's simpler to use. So that's the route I'm going to take this time. I know actually, even though I wrote positive and negative, that there are no positive real roots, right? So actually I know these are all going to be only the negative ones I got to check. So what I'd like to do is start by checking the negative ones. Negative 1, negative 2, negative 3, negative 4. Okay, we're going to do that by synthetic division here. So let's draw a line to cut off this work. Synthetic division, remember, we're at the thing that we're checking. So let's start with negative 1. Then we write out our function, which is 1x cubed, 9x squared, 26x, and 24. Right, this is the thing in the box. So we bring the 1 down first, right? 1 times negative 1 is negative 1. 9 minus 1 is 8. Negative 1 times 8 is negative 8. Negative 8. 26 minus 8 is, what is that, 18. Negative 1 times 18 is negative 18. And that's not 0. So 24 minus 8 is 6. So that didn't work. All right, let's try the next one. Negative 2. So again, same thing. 1, 9, 26, 24. I'm going to carry the 1 down. Negative 2 times 1 is negative 2. 9 minus 2 is 7. 7 times negative 2 is negative 14. 26 minus 14 is, what is that, 12? 12, right? Yeah. Negative 2 times 12 is negative 24. Oh, sweet. That's 0. So that's happy. That means we divided perfectly. This right here, this represents x squared plus 7x plus 12, yeah? Right there. Shoot, sweet. Okay, so this is the guy we're going to keep in mind. We've already found 1, 0. One of the zeros is negative 2, right? Negative 2, yeah? Okay, so I found negative 2 as a root. This is the remainder after I've divided. So the remaining roots are going to actually come from this remaining polynomial. So what I'm going to do now is I'm going to take this polynomial and we're going to focus on that guy as the new thing. Negative 2 is one of the roots. We'll find the other two from this polynomial. Okay, so I'm going to erase the top. And we're going to focus now on that polynomial that's on the bottom there. So our new f of x is just x squared plus 7x plus 12. Now, this though, this is a quadratic, right? So instead of going through that whole thing again, what I'm going to do is just plug it straight into the quadratic equation, and I don't even have to think. I just pop the thing in and see what comes out. So x is going to be equal to negative b plus or minus the square root of b squared, which is 49, minus 4ac, which is 4 times 1 times 12. 4 times 12 is 48. Oh, that's convenient. And divided by 2a, which is 2 times 1. Okay, I kind of skipped some steps, but that's just because I assume that you guys know how to apply the quadratic formula at this stage. All right, so now we're just going to simplify that thing. This is actually a nice simplification because that's negative 7 plus or minus 49 minus 48 is the square root of 1. And 2 times 1 is just 2. All right, sweet. So that's negative 7 plus or minus 1 over 2. If I take the positive version, negative 7 plus 1, that's negative 6, divided by 2 is negative 3. Or if I take the negative version, negative 7 minus 1 is negative 8, divided by 2 is negative 4. Right, sweet. So here's my other two roots, negative 3 and negative 4. And negative 2 was my last one, right? So there's my answer. Negative 2, negative 3, negative 4, those are the three zeros. And I knew it had to have three zeros because my original function was a power third, yeah? All right. That's done. Last question. Last question. Hopefully I can do it with one take so I don't have to redo question number 6 again. Let's see. Six x cubed. This is number 7. 6x cubed minus x squared minus 20x plus 12. Okay, so we're going to do the same thing. Check for the number of sign changes to start. There's 1, 2. So that means 2 or 0 positive roots. Positive real roots. Okay, now we're going to check the sign changes for f of negative x. So here's f of negative x. That's negative 6x cubed minus x squared plus 20x plus 12. Okay, so we have, let's see, what is this? Negative to negative is nothing, to positive, one change. One change means there's one negative real root. Okay, now we're going to check what are the possibilities for the rational roots. So what are my possible p's first? P's come from things that divide 12, right? That's 1, 2, 3, 4, 6, and 12. Okay, Q values, things that divide 6. That's 1, 2, 3, and 6. That means my rational roots. All right. Okay, there's kind of a bunch of them. Anything that's P divided by Q, right? But you know, to start with, just to make life easy, I'm only going to focus on the integers. I'm not going to write all my possible rational roots. Let's just look at the integer ones first. So here are some possible roots. Now just look at all the things over 1 first. So that'll be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And I'm going to start with the smaller ones because smaller things are easier to work with, right? So let's do the whole thing again. We're going to use synthetic division. We can check both positive and negative this time because there could be 2 positives and there's definitely 1 negative. So let's check. Let's see. Okay, so 6, negative 1, negative 20, positive 12. I'm going to check 1 first. Let's see. Bring 6 down. 1 times 6 is 6. Negative 1 plus 6 is 5. 5 times 1 is 5. So 5 again. Negative 20 plus 5 is negative 15. Negative 15 times 1 is negative 15, which gives me negative 3. So that didn't work. Did not divide. All right. Let's try negative 1 this time. 6, negative 1, negative 20, 12, and the same thing. Bring the 6 down. That's negative 6. Negative 1 plus negative 6 is negative 7. Negative 1 times negative 7 is positive 7. Negative 20 plus 7 is negative 13. And then negative 13 times 1 is positive 13. So it gives us 25, which is, no, it doesn't work. Okay, so those two didn't work. Negative 1, positive 1 did not work. Let's try 2's next. All right, so same thing. Let's try positive 2. We have 6, negative 1, negative 20, 12. And bring the 6 down. That's 6. 2 times 6 is 12. Negative 1 plus 12 is 11. 11 times 2 is 22. Let's see. Negative 20 plus 22 is positive 2. 2 times 2 is 4. So that gives us 16. That's a no-go. All right, let's try negative 2 then. And yeah, I know this is kind of tedious, but I don't know what to tell you. This is the best that we have. Although we didn't use our intuition, we could have used some intuition to try to guess what numbers would have come out to 0. But that's besides the point for now. Let's just try. 6, that's going to be negative 12. Negative 12 plus 1 is negative 13. Negative 13 times 2 is positive 26. Negative 20 plus 26 is positive 6. 6 times negative 2 is negative 12, which is 0. Nice. So this is the one that works. Negative 2 is a root. That's, in fact, the one negative root. So what's left over is 6x squared minus 13x plus 6. All right, so I found one of the roots. It's negative 2. Oh, negative 2. Wasn't that a root the last time, too? Okay, anyway, so negative 2 is one of the roots. Now I have to find the other 2. But the other 2 come from this remaining quadratic, right? So quadratic, I can just stick that thing into the quadratic equation and I'll be done. So here is x equal to, oh, let me write down the function first. Okay, so these are going to come from the quadratic equation. X is equal to negative b, which is 13, plus or minus the square root of b squared. 13 squared is 169. Minus 4 a c. 4 times 6 is 24 times 6. I can't do math. I just cheat. 144. Oh, I shouldn't know that one. Okay, 144. Oh, okay, this is gonna be nice. That's 25. Okay, divided by 2 times 6. Yeah, 2a. All right, now we just need to simplify that thing. Let me simplify below. So let's try to fit it right here. It's going to be 13 plus or minus the square root of 169 minus 144 is 25, which happens to be 5, divided by 2 times 6 is 12. And we'll switch to black up here. That's equal to positive 13 plus or minus 5 divided by 12. Okay, nice. It's a nice number. So which is, if I take the positive, 13 plus 5 is 18 divided by 12. So 18 twelfths. Or if I take the negative, 13 minus 5 is 8 divided by 12. And then I can reduce that. 18 divided by 12, divide both of those by 2, that's 9. Actually, no, by 6, yeah? Divided by 6, that's 3. Divided by 6, that's 2, so 3 halves. or this one is divided by 4, that's 2, divided by 4, that's 3. Alright, so I found my 3 roots. Those 3 guys here. -2, 3/2, or 2/3. And that is it. Sorry guys, that was a little bit long. Hopefully they won't always be this long. But you can watch it double speed in general if you like, because that's probably what I would do if I was you. Anyway guys, have a good one. See you next time. Peace.